Today we are reviewing a concept we've done before, and that is showing the relationship between f prime, and f double prime. And like I said, this document will help you do the card activity that we're going to do tomorrow. What I want to do for the rest of class today is work all the way through example 1, and then tomorrow we're going to spend time working on the rest of this, and then doing the card activity afterwards. Now, very important how you do these. These are very common on the AP test as well. First example says, given the graph of the first derivative f prime, find the requested information about f. So I'm going to write real big, this is f prime, and I need to know that for two reasons. Number one, it tends to get confused with f, and number two, you're going to be asked to justify many, many times through here. In calculus, when you're justifying an answer, you must use what you are given, not anything that you calculate. I am given f prime, so every justification must include or must be about f prime. Okay? So, let's start off. We've done this before. Where is the function f of x increasing based on what I see right here? Okay? So let's talk about this in terms of a number line. Okay? An f prime number line, and I know what f prime looks like. I want to know some stuff about f. So, when we do the symbols of increasing and decreasing down here, what symbols do we end up putting on the f prime number line? Pluses or minuses, correct? So if I put an increasing symbol here, that means that f prime is what? Positive. If I put a decreasing symbol, that means that f prime is negative. Okay? All I see is f prime. So what I need to look at is what is f prime as far as positive and negative. Now, once again, what is the definition of a graph being positive? Above the x-axis. So look at this graph right here. Does it start out above or below the x-axis? Above. So I'm going to put a plus sign right there because it starts out above until I get to what number? Negative 3. And then it goes below, so it's negative until I get to what? Negative 2. And then it is above again until I get to what? 0. And then it is below. So this plus and minus information is going to tell me what f is doing. So f in this case, if this is a plus sign, what symbol goes here? Increasing. That's increasing. And then it's decreasing. Then it's increasing again, and then it's decreasing. So now I can answer question A. Where is f increasing? So f increases from where to where? What's my first interval? Negative infinity to negative 3. You can put the union symbol if you want to. I'm not going to just because of space issues. And what's the next interval? Negative 2 to 0. Because, you can just do B/C. Because why? Your answer must be something about f prime. Because f prime is, you can say the word positive, or you can say the word above the x-axis. You can do it either way. F prime is positive. That's why it's increasing. Okay? And then it says decreasing. So f decreases, and you've got to put the f there, guys. You've got to be specific about what you're talking about. F decreases from negative 3 to negative 2, and then from 0 to infinity, because f prime is negative. Okay. Questions on that? I think a lot of you already had that relationship down in your head. When this is above the x-axis, that means that's where f is increasing. When this is below the x-axis, that's where f is decreasing. Oops, excuse me for making it crooked. Okay, now part B. Where does the function f have maxes or mins? Can you look on this number line and tell me where the maxes and mins are? It's pretty obvious, isn't it? What is negative 3? It's a max. I'm going to draw a capital M for max. What's negative 2? It's a min, so I'm going to draw a lowercase m for min. What about 0? It's a max. Okay? Then it says to justify. Now, we've been justifying in this class for months. Ever since we started maxes and mins. Those sentences I always made you write when you did relative max and min problems. So, and the sentences dealt with f prime also. Since f prime, who remembers what we put? Changes from plus to minus. Let's do that one first. Plus to minus at. Now, changing from plus to minus, is that the max or the min statement? Changing from plus to minus. Changing from plus to minus. That's max. So we're talking about the maxes, which is x equals negative 3 and x equals 0. There is a relative max at x equals negative 3 and x equals 0. Period. There's the max sentence. We did both maxes in one sentence. Makes it easier that way. And now we've got to do the min sentence. Since f prime changes. How is it different for min? Negative to positive at x equals, in this case, negative 2. There is a relative min at x equals negative 2, period. Any questions on that? That's pretty, once you have the number line built, maxes and mins are easy. You just look at it and go, oh, up and down, max, etc. Okay. We're all good so far. This is review, right? Do y'all remember seeing this before? Either, yeah, I got it down to a science, or yeah, I vaguely kind of remember. C is a little bit harder. Okay? C, the function f, concave up and concave down. And all you know is what f prime looks like. That's a little weird. First of all, concavity is based on which derivative? Second. So when I draw a number line for this one, it's going to be the f double prime number line. Okay? What symbol is on an f prime number line when the graph is concave up?
Like A.
Up. What sign is right here? On this number line, what symbol would you see if it was concave up? You would see a plus sign, right? And if it was concave down, you would see a minus sign. But if you look up here, when you see a plus sign, what symbol is always underneath it? Increasing, decreasing. Now, I know this says f double prime. I know this says f prime. But if these two derivatives are one derivative apart, as in one step down, the same rules apply. So if this says f prime and this says f, if I have f double prime here, this is f prime right there. You go down one step. And the same rules that are here apply to this one as well. Okay? So, do I know anything about f double prime yet? No. I do know stuff about f prime, don't I? Okay? So if these are pluses and minuses, these are arrows, increasing and decreasing. Okay? So look at this graph right here. What is it doing first? Decreasing. So I can write that f prime is decreasing until I get to where? Negative 2.5 is a good guess. Then what is it doing? Increasing until I get to where? Negative 1. And then it is decreasing again. If these two are only one derivative apart, the symbols will stay the same, okay, between here and here. So if I put a down arrow here, what symbol goes up here? Negative. You follow me? Increasing means that gets a plus sign. Decreasing, that gets a minus sign. So now that gives me the concavity information, doesn't it? Concavity is determined by where f prime increases and decreases. Let me say that one more time because it's very important. Concavity is determined by where f prime increases and decreases. Okay? That's a good thing to write down. And I'm going to summarize that again tomorrow. Okay? So, based on this, F is concave up where? Negative 2.5 to negative 1 is concave up because it has to be F prime. What's F prime doing? F prime is increasing. Yes. I was getting ahead of myself and thinking, nope, there's more to it than that. Because F prime is increasing. Exactly. F is concave down from negative infinity to negative 2.5, and then again from negative 1 to infinity. Because why? Because what? Okay. Because F prime is decreasing. I'm going to try to remember, and it's very important, the word it is not allowed in any justification ever. You cannot say because it is increasing or it is decreasing. I need to know, is it F or F prime or F double prime? It is not allowed. Okay? We're doing great. So, concavity of F is determined by the increasing and decreasing of F prime. You've got to know that. Very, very important. And I'll be honest with you. When I took calculus 30 years ago, we didn't do this. This is new. They've changed the curriculum. We didn't do this. And as a teacher, it took me a while to wrap my brain around this. So I understand if some of you are still struggling with it. That's okay. It's a difficult concept. Okay? Letter D. At which values of x does the function have inflection points? Where are inflection points found? Which derivative? Double prime is inflection points. So, what has to happen on the number line to be? Are both of these inflection points?
Yes.
Because those are changing sign, right? That's what I told you the definition is. So, F has POI. POI is acceptable for points of inflection at x equals negative 2.5 and x equals negative 1 because. I'm going to stop for a second. I want you to catch up with me. F has POI at x equals negative 2.5 and x equals negative 1 because. Now, when I taught you points of inflection, I told you that it was because the F double prime number line changes sign. But I told you today, because I started out with F prime, I can't use F double prime in a justification. I have to say something about F prime. What is F prime doing that causes the points of inflection to occur? Colin, what do you think?
Changing it from increasing and decreasing.
Okay, that is exactly right. But before you write that down, I want you to watch where I'm putting quotes in the air. F prime changes from increasing to decreasing and vice versa, end quote. How can I change that from increasing to decreasing and vice versa down to one word? Say it again. Direction. It's not changing sign. It's changing direction. Does that make sense? It's changing from increasing to decreasing or vice versa. I don't want to write increasing to decreasing or vice versa. That takes too long. I'd rather write the word direction. So F prime changes direction. Period. Are we good?
Yeah, you will.
Now, the last question that we're going to do, and I'm glad I've got a lot of time to do this one, and I want to talk about some other things when we're finished that I don't necessarily want to record, but it's a little side note. I want to sketch the graph of this. Now, the way I sketch the graph is I look at the two number lines that I've constructed right here, and I'm going to draw an F number line. And I'm actually going to put it way down here because I need a lot of room. F number line. Oops, I can't go too high because I got to have this number line in view when I do it. Can you all see that? Sorry that I'm so low. Okay. Now the F information on here is increasing and decreasing, right? So this one says I'm increasing until I get to -3. Oops, I got to back up for a minute. What numbers do I put on this line? Any numbers that are on either one of these two. So I need to put 1, 2, 3, 4, 5 numbers on this number line. -3, -2.5, -2, -1, and 0. Now they don't have to be perfectly spaced, they just have to all be there. Okay. Now, going back to this top number line, as soon as I'm done with this number line, I'm going to scoot the paper up so you can see better. It says I'm increasing on F until I get to -3. So I'm going to write INC right above that, increasing to -3. Then I'm decreasing all the way to -2. So the next two sections are both decreasing. Then I'm increasing all the way to 0, so the next two sections are increasing. And then it's decreasing after that. Everybody clear on how I got all that? Okay? Scooting the paper up. Now you can see a little better. Okay? Now, this is an F double prime and an F prime number line. I don't have any F stuff up here, but what is this really telling me about F? It's telling me concavity. Okay? So, if this says minus right here, what kind of concavity are we talking about again? We're talking down. Up to -2.5. So I'm going to draw a concave down frown in both the sections up to -2.5. Then it's concave up to -1. So the next two sections are up like a cup. And then it's concave down after that, all the way. So down and down. Are you with me? Okay. The next thing I want to do is be specific. This is a whole concave down. Which part of it is the increasing part? The left side or the right side? The left side. So underneath here, I'm just going to draw the left side of the concave down, because a piece that is increasing and down looks like that. A piece that is decreasing and down looks like the other side. Okay? The third section is decreasing and up. Which side is the decreasing of an up?
The left side.
The left side is. Decreasing and up. Increasing and up is the right side. And then increasing down, I've already done that right there. Decreasing down, I've already done that right there. Okay? Now, once again, I'm just going to take my 6 red pieces and put them together like a jigsaw puzzle. Make sure I'm stopping in between these numbers on this graph right here. Now, this problem did not give me any points that I had to go through, so I can draw this thing as high or as low as I wanted to. So I'm just going to stay kind of around the x-axis because it's a little bit easier. So I'm supposed to draw this looking thing until I get to -3. So I'm going to draw like that and just stop at -3. Stop on the x-axis. You don't have to stop on the x-axis. I just decided to do so. Now, the next piece is tiny because it only goes to -2.5, and those aren't very far apart spaced. So it's the other half of this. So I'm going to stop right there. The other half of the frown, but it's a tiny piece. Then the next part goes to -2, and it's the left half of a cup. The next piece goes all the way to -1, and it's the right half of the cup. Now, you can go up as high as you want to. I'm going to go ahead and go to the x-axis just because I feel like it. Then from -1 to 0, it's the left half of a frown, stopping on the y-axis, and then it's going to be going down from there. So it's down like so. Put the arrows on the ends. There you go. Any questions? Do you remember doing this? Coming back to you. Okay.